see anyone else. So
minimize and start your slideshow. There you go.
Okay, no one wants to know about HIS, LIS, and UCSF information architecture. Fine. Okay, so we're going to be, so purposes of a hospital information system, and now I think I should probably change this to EHR or EMR as the new terminology for a hospital information system. So in the old time, we used to think about these as hospital information systems did business computations, they allowed for communication, they did some database management, and then the concept was coined in the late 80s and 90s was this concept of clinical computing, which is really where the EMRs and EHRs came from, that you could present clinicians with information, tools, lab tests, radiology, communications, maybe reminders, maybe things that would say, oh, hey, your patient's on DIG and we see that your potassium is going up. You may need to look at that, so flags and those kind of things as a way to help physicians deal with kind of the avalanche of data that they were being faced with more and more. So clinical computing, as I said, making better use of the information at hand, provide warnings and suggestions based on this selected information, allow rapid access to medical literature, and provide the rapid communications links to other physician and care providers, originally by email, and now we're doing it by kind of an in-basket process through the EHR itself, through Apex. So you can communicate, and you can communicate with patients and other individuals. So going back to kind of the ground, so talking a little bit about database structures, because in reality, computers, especially EHRs and those kind of things, are really multi-relational databases, and they use that data to then do all the things that they do. So understanding a little bit about database structures is going to be important for us. So here's a hierarchical database structure. Okay, so the old taxonomic key, and okay, kingdom, phylum, class, order, family, genus, species, and to get down to Homo sapiens, you would have to specify the entire pathway. So it would be Animalia / vertebrates / animals. So kind of the same way you do sometimes still looking at, say, file folders within your home computer. You've got multiple branching pathways that you can go down, and to hit that one piece of data, you have to tell the system, this is where I want you to go. Okay, so that's the typical hierarchical database structure. Obviously, to get at one piece of data can be relatively fast, but to search through that can be relatively slow. Okay. Relational database structures then essentially think of them as a two-dimensional grid. Okay, so here's a relational database where I've got accession number tied to a medical record number, tied to name, and tied to a test. Okay, so this might be the accession number relational database that relates the accession number to what tests were ordered. In order to specify one point of data in this, okay, all I need to do is give it the coordinates. So say this, and I can hit last name. So I just need two coordinates to specify each data point within that table, right? I just need to know what's on the X and what's on the Y, or X and Y.
The mouse pointer is reportable now, so.
Oh, okay.
That might be better.
Yeah. Okay, so, all right, thank you. So all I need to know is specify something in this column and something on that row, and I can get to any data point within the matrix. So that's a relational database. That doesn't get you very far, and it's not very flexible. Obviously, data is much more complex than that. So say I wanted to know, well, what are the components of a CBC? Well, this flat file arrangement won't allow me to display the, okay, I've got 10 different members in a CBC, and I want to be able to display those out. You can't do it in this flat file structure. But I could link this to another file, and that's the multiple relational database structure. So essentially, I can have a flat file, a matrix that's patients. So this would give me, here's my medical record number, and if I specify the medical record number and I want the last name, then I can get Hamill. Okay, The medical record number might relate to another two-dimensional database that is orders. So, okay, I can look up by Hamill, I can get the medical record number, the system can then track the medical record number and say, oh, there's a CBC, and then the CBC can be tied to another database that shows information on the test. Here's the test number, result number 1, the units, the normal range. So these are called pointers, and that's what ties these multiple databases together, and that's the concept of a multiple relational database structure. And that is really the basis of virtually all of our systems today, that it's set up in this fashion. It's multiple tables, two-dimensional, that are tied together by pointers that link those tables. Does that make sense? Okay, so now you know. Okay, so in terms of HIS issues, and some of this is kind of old school because we really don't do a lot of this anymore, but just so you have the background on it. So issues with HIS and development of HIS and EHRs is, okay, are you going to have what's called an interface departmental versus a single central system? Okay, so the VA has a single central system. Everything is tied into one big box, okay? There are advantages and disadvantages to that, and we'll talk about those, okay? Is it a system for information transport, so essentially a network connecting different systems, or is it a system for total information storage and retrieval? And these were all questions that had to be asked in developing an HIS system. Okay, is the data entry going to be by the primary care staff, or is it going to be via clerks? Different sets of parameters that you had to set up for that. Were you going to develop the system in-house versus purchase it? And there are still some places that, yes, are still on in-house. When we went to Marshfield Clinic is entirely home-built. Their entire EHR, their lab system, their radiology system, everything is entirely built and owned by them. You hardly ever see that anymore. Were you going to maintain and operate the system or contract with some external vendor for that? Were you going to put it all on a mainframe? Yeah, versus servers, which is, you know, our typical process now is multiple servers, and the old, you know, run it out to lots of different desktop computers and PCs. Well, we have PCs as clients, but they typically can't hold the entire system, you know, within them. So, you know, typically a server and mainframe process. And then, should all computer purchases be part of a larger plan for the overall institutional computerization? Yes, I think everyone would say, yeah, you don't want things just done, you know, radiology gets their own thing, and lab gets their own thing, and billing gets their own thing, and they don't talk together. So, yeah, these need to be integrated. There needs to be a thought process wrapped around developing an HIS. So, here's essentially the interface CPU system. So you might have a lab computer like SunQuest. You may have a pharmacy computer. You might have a radiology computer like PISIS. You may tie all those to administration and finance. So this might be your registration, discharge, and billing processes. And then people get at that information out on the wards via some kind of ward inquiry terminals. In this system, because this one's coming from the lab, and this was actually the system we had at Mount Zion when I first started there. Radiology had a set of PCs out on the ward. Lab had different PCs out on the ward, so if they wanted to look up lab data, they went to one. If they wanted to look up radiology, they went to another. If they wanted to look up, you know, other things, there were just multiple sets. Kind of a clunky system. Okay.
Before like HL7 came out?
Actually, this was during HL7.
Okay.
HL7, when most of these things functioned on an HL7 standard, but they were still, these systems didn't talk. There was no centralized system that they all talked to and then went out. Now, you could replace something and have it, say, an interface engine where all of these systems could interface and then run out to one set of terminals out. Okay, different way of doing it. Okay, so here's the integrated centralized system. This would be much more like we're getting to with Apex or what the VA has, where you have essentially one centralized database that all, radiology, lab, admissions, pharmacy, all tie into this, and they all use a central system that houses all their software, and then the ward terminals for inquiring orders are fed off that. Okay? Problem with this kind of system is that, well, the lab is dependent on whatever software they're going to use for the main CPU. Apex has a laboratory system called Beaker. And yes, we could have looked at Beaker as being a replacement for SunQuest. Not ready for prime time. Everyone felt it was not going to be, really usable at a large academic quaternary care center like we are. But in time, it may become more robust. And yeah, I could envision a time where instead of having a separate lab system, we have one major system like Apex that incorporates a laboratory functionality in it. Okay. The problem with this in the past was that there were probably better systems out for each of the individual services, like SunQuest, like PACS system for radiology, than they had in any kind of centralized, standalone, one system feeds everybody system. So most labs in radiology wanted to get kind of best of breed. They wanted to have all the functionality for the lab or for radiology, and there really wasn't one system out here that could provide all of that.
So Apex offers the software as well. We just don't use it.
We don't use it, right. Just because it wasn't really ready for us. They don't have blood bank. They don't have microbiology. They don't have a lot of things we really require, and so we would have had standalone systems for those, and that's more interfaces, more clunkiness. In time, I think they will develop that. So it's kind of interesting. We're kind of going, it started out back in the 70s with, kind of centralized systems that hosted everything and did everything. And then we moved to kind of more integrated systems, and now we're kind of moving back to centralized systems that kind of host everything. This is probably the more common that we have right now, where we have, some kind of lab computer like SunQuest, some kind of radiology device, all going into a centralized host that then, and this would be Apex at this point, and then the ward terminals just access off of that system. And this is probably, if you looked at probably 90% of institutions are probably built around this kind of model right now, rather than either the centralized CPU or the entirely separated systems that don't talk to each other. The advantages of this is obviously once I can get all the data into this system, now I can do those checks. Now I can look at pharmacy and lab data. Now I can look, across systems and try and do that functionality that was kind of the concept of clinical computing. Okay, in a completely separated system where SunQuest and pharmacy and radiology don't really talk to each other, you can't do that kind of cross-discipline checking that this kind of system would allow you to do. Okay? All right. This is old, and I've asked him for an update on it, but just to show you how complex this thing can be, if you look, there's the lab, okay? And so we connect with the ADT, which is the admissions, discharge, and transfer system. Used to be called IDX. That's now gone away, and Apex now is serving that function with their system Cadence, okay? That store, that's gone away now. That's Apex, okay? And everything went through this interface engine. So you have essentially that kind of, although we had separate systems, they all went through an interface system, and now this functioned as the centralized data repository. If you renamed this as Apex, that's where Apex sits. So we still talk through an interface engine to Apex. Okay. This has gone away because this is now part of Apex, so this is gone, and I'm going to get an updated one of this. But you can see how complex the system is. And a system like this now is completely dependent more on these pipes than really the separate systems. I mean, it is dependent on the separate systems, but if the pipes break, it's like those systems don't exist. Okay? So if my pipe broke between SunQuest and either the interface engine or the pipe between the interface engine and Apex broke, Nothing's going out to the people that need it. Okay, I'm back to doing paper reports at that point. Okay.
Are those pipes, is that an accurate representation of the pipes? Like if that pipe that connects all the different services together breaks, do they all, are they individually connected? They're individually connected to...
Actually, Enrique might be able to answer that question better. There's certainly redundancy built into the system so that, like, if a server went down, we can branch around that server and go to a different server. But if the main interface between, and there's a single interface between SunQuest and the interface engine, if that goes down, or if there's something a little wonky with the network as a whole, yeah, nothing goes out. Yeah. So these kind of systems now become extremely dependent on your network hardiness, your infrastructure, and how redundant it is. So, as long as I can keep the network up, I'm okay. But if the network goes down for any reason, or portions of it go down that are critical, or the interface engine goes down, then the whole thing grinds to a halt. And you can imagine in an Apex environment, if everything went down, and now the docs are totally dependent on a computerized system, they have no paper anymore, you can imagine what the impacts would be to the system as a whole. So these become vulnerable at that level. So let's talk a little bit about networks. So there's the physical network, which is the wiring and the routers, and then there's architecture and communication protocols. So twisted pair wire we still use. I think 6 is the standard now, Enrique. 6 pair wire, or is it 8?
It's 8.
8 now. Coaxial cable used to be to link like servers and major hubs of the system. And coaxial cable was pretty good because it was pretty hard to tap, and it had a pretty good bandwidth, and you could do both video and audio and data across it. But it's pretty unwieldy. If you ever hooked up your own TV with that, it's not easy stuff to work with. So really moving off to more now fiber optic cables, which have their own issues. Fiber optic cables, essentially you have to have 2 lines, right? Because they only go one way. So dual communication, you have to have 2 fiber optic strands to be able to do dual communications. Actually, with some of the newer systems, it runs one way and then it runs back the other way. But a lot of the current systems require 2 fiber optic strands to be able to communicate. But much higher bandwidth, again, very difficult to tap into, so very secure systems. Not prone to a lot of electrical problems, but again, a little unwieldy. There are some systems now where instead of just a cable, they actually blow the fibers down conduits, kind of odd stuff. Okay, so that's the physical nature, and we still use most of these in portions of our network. Okay, network architecture. So in terms of, and this would be, say, in the laboratory, you can have a backbone, you can have a ring structure, or you can have the what they call a star structure. So each of the darker lines might be a coaxial cable or some other higher speed connection pipe, a bigger pipe, and then each one of the smaller ones might be your twisted pair cable that goes directly to your PC or to your instrument. Okay, so multiple configurations of that. And then you can take those and start hooking them together with a bigger pipe. And I think a lot about this is like it's almost plumbing. The more things you're hooking together, the more width I need, pipe I need, the bigger pipe I need to be able to hook them. So a LAN bridge, so taking a local area network or a LAN and connecting them with a LAN bridge to make a wide area network, a WAN, or an extended area network, an ELAN. So just so you're familiar with those. And again, the more things you connect together, the bigger pipe you need. And then finally, at UCSF, we have the universal wiring plan. So this would be, say, like at Parnassus, Moffitt Hospital. You're going to have down there a main distribution frame where, say, like a T1 line comes in. That will then go to intermediate distribution frames on each floor with typically something like a fiber optic cable. And then from there, you may be doing twisted pair wire out to PCs or other devices that are on that floor. Okay. Okay, so that's networks and just the physical nature of wiring something up. Then you have to have the communications models. You mentioned one, HL7. We'll talk a little bit about that. But so you need to know that there's lots of standards institutes and areas within both government and private sector that are working on trying to standardize a lot of this stuff. So the Open Systems Interconnect, or OSI, which was one of the original standardizations. It was done by the ISO, the International Standards Organization, and you see ISO a lot. The knobs and stuff in your car, those little symbols on them, those are all ISO approved symbols, so there's consistency among car manufacturers. So, your windshield defroster has the same image that it would in a Volvo as it would in a Ferrari. Okay, but the OSI defines 7 levels. So applications, so that's the software, how it presents it, what a session is, how you transport, so packaging, the network itself, what data links are going to be required, and then the physical nature. And so you had 7 levels of standardization that most institutions and most vendors are using now. In terms of U.S. computer standardization efforts, these are all the groups that are involved, and I won't go through all these. The one that's most important is the one you already mentioned, which is HL7, or Health Level 7, and that's the one that for all medical devices, instrumentation, radiology, scanners, LISs, EHRs, all of those are HL7 compliant. Okay. So vocabulary standards, and we were talking about this a little bit earlier. So there is ICD-9, so that's classification of diseases, and then there's CPT-4, which is the current procedural terminology, 4th edition. That was going to be replaced by something called LOINC, the Logical Observation Identifier Names and Codes, which was, instead of the 5-digit CPT code, that was a 7-digit code, and it further refined and gave more granularity than CPT-4. So CPT would give you something like serum sodium, and there's a CPT code for that. Okay, LOINC would say, okay, but it's a serum sodium done by this methodology, direct ISC, indirect ISC, flame photometry, if anyone ever did it that way. Okay, so it really specified it down to a much more granular level so that there could be better communication between health entities about what the exact test was or procedure or whatever we were using. So LOINC was meant to replace CPT-4. As far as I'm aware, Enrique, LOINC is dead, right?
It's still being used.
Still being used. I mean, we're using it. We've got it in Apex, but I don't know exactly how much they're making use of it. Eventually, CPT-4 is going to be replaced by ICD-10, which initially will do all the ICDs, but will incorporate procedure codes. So it will be a combination of both the ICD-9 and CPT-4 process. But it'll be one set of codes that kind of covers both diagnostic and procedural information. Okay, not out yet. And the problems we have with CPT-4 and ICD-9s, I think, are going to look very small compared to the problems we will have with ICD-10. SNOMED, so if you're in pathology, on the anatomic side, there's a SNOMED system, which basically allows you to say anatomic site, pathologic diagnosis, and tie those two together. NDC, the National Drug Codes, Unified Medical Language System, and then the International Classification of Primary Care, which actually got rolled mostly into the ICD-9 process. So just so you know some of those terminologies. Okay, so electronic medical records, as we're dealing with right now, combines inputs from multiple sources for display and storage. Allows for online charting, so no more paper records. Allows for electronic orders to be placed. That's where we're having most of our headaches right now. Allows those alerts and special information to be provided to the caregivers. And then has the electronic signature capability for the orders. So everything is contained within the system, and they're, I don't know we'll ever be totally rid of paper, but a bunch of it will go away and has gone away with the implementation of EMRs and EHRs. What are the advantages? Well, rapid access to patient data. You no longer have to hunt down the patient's chart on the ward. Anyone can access the data from anywhere. So multiple people can access at the same time. It's not one chart. Now anyone can have access to it. You can have remote access, rapid relaying of orders. So now we're getting orders coming across instead of by paper. Now we're getting them electronically into SunQuest. It has its own problems, but eventually that will be a much better system. The capability to produce the alerts and reminders, rapid communication between caregivers, ease of audits and research, and then improved legibility of records. So you can actually read those progress notes that that someone wrote at 2 o'clock in the morning. Disadvantages, because they aren't perfect, unauthorized access. Used to be you'd have to come up to the ward and actually pick up a chart to be able to access that information. Now that it's electronic, it's hackable. We have to put up security safeguards and those kind of things. We'll talk more about that with HIPAA. You're dependent on that network and the system itself. The system goes down or the network goes down, you've got problems. Typically slower input of information. People are much quicker jotting notes than typically entering either on a keyboard or even with dictation. With dictation, it's got to go through a process, and yeah, we're using Dragon Speak, to do real-time voice recognition. But even with that, it's a little bit clunkier. He's got to make corrections. Requires a huge amount of cultural change. People who are used to doing things on paper now, which is very fluid, and you can use paper in a lot of different ways. Now you have to kind of do it one way, one standard way. Okay, so the process change and cultural change are a requirement. There's less flexibility, so there's process exceptions. For the lab, test order issues, as we're dealing with now. It used to be the doc would write something, and a clerk or a nurse would interpret that and provide us with those orders. And so the clerks and the nurses knew the lab manual, they knew what to order. The doc would just write, hey, I want this kind of test. Now the docs are doing it. And now we're seeing things like, oh, huge spike in orders for creatine. Why? Because they're misreading it. They're looking for creatinine. They're close together. And instead of looking at the word, they're just picking, oh, that looks like it, I'll check that one. And so we've had to actually remove creatine as an orderable test. Wow. Because we were getting hundreds of them. And usually we got like maybe 6 a year. So, lots of that interpreter function that took what the doc wanted and turned it into something that was usable by us is gone now. And so the docs are ordering things kind of crazily. So this is something we've had to learn and something that I think we'll get to UCLA and say, you got to watch out for this. Okay, let's shift off. So that's hospital information systems and the electronic health record. Let's move off the laboratory information systems and what they do. So LIS functions to track and record test orders, patient samples, test results, provide reporting, quality control management, billing, and system administration functions. And so you have to have software routines that create right to maintain, query, and preserve those relational databases. Okay, and then databases may be hierarchical, hardly ever used anymore, or relational, much more common in the current LISs, and allow us to do these functions. So LISs grew out of two different worlds, hospitals and reference labs. Okay, and now we're moving towards hybrids, and most systems are now hybrid now, and I'll show you what that means. So hospital LIS design features, things that hospitals need is we need a cumulative patient reporting. We need to be able to, especially on the inpatient units, now I can look it up in Apex and I can trend it and I can even graph it in Apex. If I want what's the patient's glucose been doing. Previously it was, and when I first got here, it was we printed out a cumulative report for every patient every night. And so it would be multiple pages, but all of the glucoses would be in one place, so a doc could look at all of them simultaneously. Okay, the EHR has taken that away, but we needed cumulative patient reports and records. We needed a hospital information system and an admissions, discharge, and transfer interface because we did admissions and discharges. Okay. We need microbiology subsystems. We needed blood bank subsystems. We needed QA and CQI activities. Probably didn't need much in terms of billing and accounting because typically the medical center took care of that. We just fed them information about what we did, and they would do all the necessarily billing. We didn't really need client-specific system options because our client was the hospital. We really only had one client, or maybe the clinics associated with that hospital. So we didn't have to have a lot of flexibility in terms of client options. And we didn't really need multi-site options because it was typically the lab for that hospital. Now, as we started banding hospitals together and more labs needed to be, functionally like we have now with Mount Zion, Parnassus, and China Basin, where it's really, I consider it one lab at 3 sites kind of thing, and we function as an integrated whole. Okay. Previous, in the hospital environment, LISs didn't need to do that until, probably the last 10 years. Okay, on the reference lab system, reference labs had very advanced accounting and billing features. Why? That was their business. This was why they did it. So they had to have very robust systems on the reference lab side. They needed to have competitive client-specific options and features. If I was feeding out to a bunch of different private practices and group practices, and they wanted to do things different ways, I had to be able to provide that flexibility or I was going to be knocked out of the market in terms of my ability to be a reference lab. Certainly multi-site testing capabilities because places like Quest and LabCorp have laboratories spread across the United States. They needed to be able to interact in kind of a seamless fashion. They typically did individual sample session-based reporting. They didn't need cumulative reports because they took in one set of samples, turned out one set of results, and that was it. Somebody else, like either another laboratory that was sending reference work to them or the practice's own record, kept track of all the information. So I didn't need to do cumulative reporting for a patient. Some offered it, but not much. They typically therefore had primitive trended reporting features. They didn't need an HIS or ADT interface because they weren't doing admissions and discharges. So reference labs didn't really need to do that. And up until recently, they didn't much need microbiology because reference labs didn't typically get a lot of microbiology. The samples were too unstable to ship them out to a reference lab. And they didn't have blood bank features because they didn't have blood banks. Okay. So the hybrids then include all of these. Sorry, I went forward and then went back. So the hybrid LIS now, the ones that have remained functional, like SOFT, like Cerner, have all of these capabilities. So they've taken from the hospital side all the things that the hospital needed, and they've taken from the LIS side or the reference lab side all the things they needed and put them together. So they offer all of the features that the independent type systems used to offer. Does that make sense? Okay. So LIS functions in a hospital setting for us: patient registration, order entry, testing and result entry, inquiry, reporting, quality control, billing, and then some kind of storage. So let's go through those. So patient registration, for us, we can get it via the laboratory information system. So I can register a person in SunQuest. So for our outreach clients where we're not going to get a medical record number, I can still get them in. We have a way to put them into the system without use of a medical record number. Typically, we create a medical record number for the outreach client. So University of Hawaii has an outreach number, but mostly we're going to get them from the hospital information system. Yeah. Question?
No.
Okay. So that's the registration function. So that's getting patient data into the system. I also need to get patient data out of the system. So I need to be able to discharge patients out of the system. And I think we're set up for a year now. Is it a year of no activity that we ought to discharge a patient? Or is it 2?
Remember.
Yeah, I don't remember either. But eventually, especially at a place like this where patients may come here for some very specialized service and then go away and never come back again, you don't want to keep those patients in your laboratory system. We need to keep the records in the EHR, but we're not going to keep them in as active patients. You just have a huge database overhead to keep all these inactive patients present. So after a period of time, you need to get them out of the system. Okay, so we can discharge them out of the system. You're going to need to do updates and corrections. So, patient came in, I got the age wrong, I didn't have a sex, I needed to update that, then something was wrong with the name. I need to be able to correct that data that's in the system. Most of that will come across from the HIS, so when they do corrections, it flows to us and it automatically updates our information. We also need to do merges. So a patient comes in as a John Doe, comatose, comes into the ED, don't know who he is, she is, need to do that. And then once we find out who actually the patient is, if they've got a medical record already, we need to now merge those records. That's a tricky process, and you got to make sure you do it right. Because once you merge data, pulling it apart is almost impossible. So we have checks and balances on that to make sure that, when we do a merge, it is correctly done. Now, we just recently loosened that up because we were getting merge messages from Apex, and we're now relying on Apex to make sure that they are right in telling us to merge those two patients' records. And the problem being is if too many things had changed in the SunQuest system, it would automatically reject it and put a hold on it. And the only people who could break that lock would be the LIS staff, since they weren't here 24/7. Then we sometimes got into the process of a John Doe coming in. We just had one of these a couple of weeks ago. Came in within hours. They figured out his name, re-registered the patient, and now we've got a blood bank, and everything is all messed up because they've got orders under John Doe, and now it's really Tim Hamill, and we hadn't merged those two. So, okay, but patient registration. Okay, order entry. Assign, so in a paper world, and now actually even with electronic world, we need to assign an accession number, because in the laboratory, that's kind of how we look at a set of samples, is an accession, okay? We may also assign container IDs, so each sample within that set of samples, so I can have all blood samples from a patient, a red top, a gold top, a blue top, purple top. That can be one accession, but each one of those sample tubes should have a separate container ID. That way I can put them on my automation system. It reads that container ID, understands what sample type that is, and now can process that sample and do the appropriate testing on it without any human intervention or little human intervention. So accession numbers and CIDs. I need to be able to retrieve that patient information. So I may need to know about age for my normal ranges. I may need to know sex. I may need to extract patient information to make my report. I need to assign a specimen type to it. So is it urine? Is it a body fluid? Is it blood? Is it CSF? Is it something else? Microbiology deals with this a lot. I need to enter the ordering MD. And is that the billing MD? Well, if it's a resident, no. I have to have the attending's information to be able to bill it out to, so I need both of those pieces of information. And then, are there any other physicians that need to get that information once I produce the report? So those are copy twos. Most of this eventually will be handled by Apex, and we won't have to deal with a lot of it, but currently we still do. I need to enter those diagnosis codes that I'm getting for my medical necessity checking. We'll talk a little bit more about that. I need to enter any test orders and comments. So things like, I want you to fax this to this number, I want you to call it to this number, those kind of requests that come in with the orders, or comments. Things like, this is a pre-dialysis sample, this is a post-dialysis sample. You don't want to mix those two up, and you want to make sure that the clinician knows which one is which when you report it. So those kind of comments may be needed to enter at the time of order entry, and then assigning timestamps to it. When was it collected? If I know that and I can enter that, when did I actually enter the order into the system? What was the receive time? What was the result time? So I can track each point of my process through and make sure that, are there any bottlenecks? Okay, I may generate work aids, so specimen labels. So when they're coming in, and we're still doing it when we're getting in samples that aren't previously barcoded, don't have our container ID barcode on them, I now need to produce those labels and relabel those tubes so that my systems can now look at them. I may create aliquot containers, so if I'm going to have to spin it down and create an aliquot to send out or ship down to China Basin, I need a label for that. I may generate work lists for each section so they know, okay, I've got 15 of these coming in. Do I have all 15 of my samples? Am I ready to go on this test process? Phlebotomy lists. We're using the CareFusion device. We're developing collection lists for those. Entering comments, doing modifications to the order, so change in order that was a creatine that I'm now going to change to a creatinine. I'm pretty sure that they ordered it wrong. And then information lookup, lab manual, any kind of handling prompts. So this thing needs to be refrigerated, centrifuged, and frozen immediately on receipt. Those kind of things are all part of the order entry process. Testing and resulting then, I can print out or create a pending list for the sections. And if you go out in chemistry right now, you'll see that big television screen we've got that actually shows them what's pending, and things will change colors as we get closer to the turnaround time cutoff for those samples, stat and routine. That helps a lot. Allow sample loading and verification on the instruments. My instrument interfaces are part of that, so interfacing to all my major analyzers. I need to be able to do keyboard entry, so things like manual differentials and urinalysis. I may need to enter manual results, so it's a manual test. I'm doing an RPR or a VDRL where it's not an interface test, it's not an instrument-based test, and I need to then enter that result manually. I may want to do delta checking, which is looking at current result versus prior result and seeing, do I think there's been a significant change here that I may question a result. Do result verification. So yeah, this result looks good, and I will release it into the patient's record. Enter comments such as it was hemolyzed, it was lipemic, that may cause result problems, or this was a critical value, I called it to the appropriate clinician, and I document that in the record so that it's there. And then result corrections. Oh, I think I had a problem with my instrument. I need to go back and check all these samples, and there might be some that I need to change the results and update those. Whenever we do a result correction by CLIA, the original result has to remain present. I can't remove it and replace it. So typically ours will say corrected result. The new corrected result is in the result field, previously reported as, and here's the old result. So that, you know, if a clinician made a treatment choice based on that incorrect result, there's a record of why they did it. It didn't just disappear from the record, and they're going, oh, no, it said the potassium was 9. Okay, quality control. So typically the LIS can function for this, so we input for all of our instruments, for a lot of our, certainly our interface instruments, the control ranges for our controls. We then use statistical rules, the Westgard rules. We'll talk a little bit more about those. Run the controls, the system collects that data and graph, and we can produce these charts out, and then produces alerts when we void the rules. So have you seen a Levy-Jennings chart? Okay, so this is what a Levy-Jennings chart. So you have a mean, typically 2 SD, and then you watch, and you want to see the controls bouncing around, you know, the mean. This kind of thing starts throwing flags. Okay, you're on one side of the mean consistently, and that's, you know, you may still be in control, but that's a clue to the technologist that you may want to watch this. Something's going on. You know, we're not doing this nice bouncing around the mean type of thing that we really want to. Westgard, Dr. James Westgard and his wife developed the Westgard rules, and that's him, and he's actually still alive, and it updates these Westgard rules. So he's got a whole bunch of statistical rules based on the Levy-Jennings that say when you are in control and when you're out of control and when you need to look at things. So things like the 1-3S rule. If you're out 3 standard deviations from the mean, you're out of control. Something's wrong. You need to recheck that instrument and look at what's going on. The 1-2S, where you go from, okay, I've shifted more than 2 standard deviations in an opposite direction. Okay, probably want to look at that instrument. Might still be in control, but I'm going to look at that one. 2 times outside of 2 standard deviations, okay, that one probably is going to trip a flag that I'm out of control. 4S rule violations. So he's got all of these different violations. Standing on one side of the curb, so 4 times out of 1 standard deviation. The 10X rule, 10 times, on one side. All of these different rules that he's developed to say you may need to look at things. Pretty useful. Okay, Inquiry, so I may need to go into the system and someone's calling me up and asking for things, so I need to look at orders that have been placed. I need to look at my test status. I need to look at results. Lookup method may be by name, medical record number, accession number, other things, but you need to have multiple ways to get at the information. How much data do you keep online versus when do you archive it into a different format? Might be a little harder to get to when it's archived, but it keeps your system overhead in terms of the database size more manageable if we take things off. Currently we have 2 years online.
We actually increased that to 5. So we have
Online, not archived?
Oh, online 1 year.
1 year, 1 year. And then archive, we go back 5 years, but then you have to do some special steps to get into the archive data. And then being able to look at trended data if someone wants to see what's going on. We can usually do that out of the LIS, but a lot of the EHRs now have that functionality. Reports, okay. So in both our paper reports and in the electronic medical record, tests and test groupings, deciding where things go. And sometimes it's out of our control, but things like Factor V Live, where do you put that one? Does it go under your molecular diagnostics, or does it go under COAG? Okay, docs may want to see it in different places, and you may not be able to please them all. Usually we've given this up to the EHR and said, you guys put it where you want to put it. We're just going to give you the result. You guys can decide where it is, and then you can leave me out of the equation. In terms of the results, then, we need the test name. We need the actual result. If corrected, the original result must remain. The units, if applicable. Some tests don't have units. The normal range, if applicable. Flags, so high, low, critical, high, low. Comments, so those order entry comments. Typically instructions we don't put on the report. I'm not going to say, fax this report to so-and-so. That doesn't go in. So some of the comments that we entered at order entry don't go onto the report. We have specialized ways of entering those so they don't go on the report. But the sample identifiers like pre, post, or, I'm doing a localization study, and this came from the right superior adrenal vein, okay? I need to be able to specify those so the docs can interpret the data. Sample comments that we put in at the time of resulting, so hemolyzed, lipemic, and then any documentation things that we put in all appear on the report. Performing lab has to appear on the report. So on our reports it says UCs have clinical labs Parnassus. If it's done at Mount Zion or China Basin, you'll see a little MZ or CB next to the result, which footnotes and says this was performed at China Basin. Microbiology is an exception since virtually all of that is done there. Those are all keyed as China Basin labs. But you have to have the performing lab. If I send it out to Quest, then I have to specify in that result that this was performed at Quest with their street address of the lab that did it. Okay? In terms of, this is for paper reports, because we don't really have this in the electronic one, but the header information, which would have the patient information, so name, medical record number, date of birth, sex, all that information, the ordering MD information, the lab information, so the street address and the director's name, and the director information, as I just mentioned. Then in the footer, you might have interpretive information like what these different flags mean, just about out of time, and then you might footnote any comments so that it doesn't clutter up the report. So instead of putting a big comment on something, or a lot of our normal ranges where I've got to give you kind of a table like on cholesterols. This is desirable, this is borderline, this is out of range, and I'm going to give you all that information. Rather than put it in the body of the report, we footnote it so that you can refer to it, but it's not cluttering up the report itself. In terms of reporting, inpatient reports, I mentioned the cumulative reports we use to print every day. We don't do these. You may want to print stat reports like to the emergency department. Now with EHRs, that's going to them directly and they get alerted. Discharge reports so that you could send it to the referring physician on the outside, everything that was done on the inpatient stay, or for convenience for dictation, so the docs have everything there in front of them at one time. Obviously with EHRs you don't really need that. Outpatient reports, the concept of interim reports and final reports, because tests come back at different times, you may want to say, well, the CBC and the sodium and the other chemistries, those came out today, but that test I sent to Mayo isn't going to come out till next week. I don't want to hold up the CBC, so I print that as a interim report and say, okay, that thing to Mayo is still pending. And then once that Mayo test comes in, I may either print another interim with just that information on it, if the doc wants it that way, or I may reprint a final report that has all of the CBC and chemistries plus the Mayo, and that way the doc can pull out the interim report I sent them, stick in the final report, that so it keeps their charts nice and small. Obviously, with electronic reporting, a lot of this is going away. If you print reports, then how are you going to sort them and order them by location, by physician? Do you want to do remote printing? So I'm actually printing at a clinic or printing in the emergency department to give them information quicker. Do you print graphic reports? Some clients want graphic reports rather than kind of textual reports. How many copies you're going to print, copy twos, those kind of things. Archiving LIS data, well, what are you going to archive? When are you going to archive it? And how are you going to archive it? So not all things do you really want to archive, over a long period of time. All of our results eventually go to the patient medical record, and Apex will be the final repository. So, I don't have to keep things forever, and there may be things that I don't want to archive, like, well, do you really care what the sodium was 5 years ago? You might care what the CEA was 5 years ago. You might care what the PSA was. There are certain tests that are necessarily appropriate to archiving. With really modern storage systems, we pretty much archive everything. This used to be more of a problem 10, 15 years ago when storage was rather expensive and we wanted to keep the overhead down. When do we archive it? After 1 year. Right now, it's going into archive. And then how do we archive it? Tape drive, CD, DVD, Blu-ray disc, archive it to another terabyte drive, the cloud. I mean, there's lots of different ways to archive this data now. System administration, we've got to maintain the system, so updating test tables, updating doctor files, updating our employee files, particularly with security and bringing in new people, and when people leave, make sure they're out of the system and can't get back in. And then things like creating billing files, workload reports, so that for each test I have a workload minutes, so I can keep track of how much workload I've got, which makes me justify to the medical center how many staff I have, those kind of things. Special section needs, so blood bank and micro, real quick, we'll run through these. These are two areas that need real special LIS functionality that is different from hematology chemistry. So in blood bank, I need order entry, so I've got tests, but I've also got product requests, okay? Versus products. I may need to enter products into my inventory so I know what's there. I have specialized data needs in terms of the type of product, the blood type, when it's going to expire, a lot of different things that I don't really have to worry about, say, in chemistry. Prospective screening information, so I need to have all the information on the screening of the product. I may want to pre-screen patients with information, so there may be information that I want to be able to put in or extract into the system in terms of screening for the correct blood type, blood product, and then reflexed orders. So, okay, if I've ordered this kind of unit, I'm going to do this kind of testing afterwards. We tried to get that in, so you order a platelet, you would reflex do a platelet test, and order that. We haven't been able to get that in. Resulting, I need standard results, so a Coombs test result versus a product. The product has been crossed, it was released, those kind of things. Automatic interpretation of, say, the ProView, so I can say, okay, this patient has this kind of blood type. Reflexing orders, as we've mentioned, product availability and disposition, and then something for transfusion reactions. I may need to report out the test, the products available, the products transfused, transfusion workups. I need different quality control, a lot more temperature and other types of checks. Different archiving, because there's typically different rules around blood bank in terms of how long you need to keep data relevant and available. And then management features such as inventory control, look back, and then utilization data, MISBOS, those kind of things. Micro,
Yeah, there's a co-ed.
I guess.
Okay. All right. Well, the rest of this is pretty straightforward, and you can just read through it. Sorry, we didn't get to the rest of this. I ran out of time. Okay. I'll send this to you. You can see it and just read through it. If you have any questions, give me a call. We can talk through it. I apologize. We ran out of time. A little slow. Okay. Can you just leave that on there so they can get to it, or shall I send it out?
Oh, I'll